Hello, today I'll be explaining my final exam. Lesson title is Equivalent Fractions, and the essential question is 1/2 only equal to 1 over 2? And this can be opened up to a broader question, as is 1/4 only equal to 1 over 4, or 1/8 only equal to 1 over 8, just so students can start thinking about, is there other ways to describe 1/2 and 1/4 with other numbers than just 1 over 2 or 1 over 4. The lesson rationale is understanding equivalent fractions are a vital role in upper level mathematics, and as students begin to increase in grade level, they use proportions, they start multiplying and dividing fractions, they need to reduce fractions quickly. There's a lot of different equations that need the understanding of equivalent fractions. It's also very useful when doing like mental math in your head. Whenever you're doing day-to-day mathematics, I use equivalent fractions quite a bit, actually. Common Core standards are CC 213C1. It's to explore and develop an understanding of fractions as numbers. The materials we're going to use today are just Cuisine air rods, Active Inspire software for students and teacher, a projector and a screen. The anticipatory set is the teacher should assign students into partners and give each group a set of Cuisine rods, tough to say. While the students are talking and exploring the manipulative, the teacher can set up the projector and the screen and allow the students to get all the playing out of the way. Alright, first objective. Students will understand how each rod is representing according to the largest rod by the end of slide 2. This level of Bloom is understand, because they're just understanding how the rods are used in proportion to their size. And yeah, that's how we go. So, procedure. Start out with the anticipatory set, and then open up with asking students the essential question. Is 1/2 only equal to 1 over 2? After this, you can delve into the lesson and ask students how many differently sized rods they have, which is 10. So, now you begin slide 1 of the Active Inspire. Ask students which the smallest and largest rods are, and then ask them for the one in the middle. So they have to determine the smallest, the largest, and then which one is right in between. The colors of the rods are given on the slide so they can see which is which, and then they're asked how many white ones make one orange, because white is the smallest, orange is the greatest. The answer is 10, which is hidden in magic ink to the right of the problem, and upon answering that, ask the question what fraction of one white would be out of one orange, which would be 1/10. Then, as you go on, you do the same procedure for the yellow rod. Students should be using their rods, obviously, throughout the entire lesson, and they can see how the fractions, like how you're getting these numerical valued fractions. So 1 yellow would be 1/2, because it takes 2 yellows to make 1 orange. Same goes for white. It's 1/10, because it takes 10 white to make 1 orange. The fractions of each rod is hidden with the magic ink to the right of the rods, and briefly just make sure students know that the orange is equal to 1, and that's what the whole is. So after that, you move on to slide 2. Slide 2 has students figure out the numerical fraction for each of the other rods, and they can find this by using the same method as the previous page on page 1. By doing this, they are actually subconsciously figuring out what equivalent fractions are, and this is just a great way for them to learn it without even understanding that they're learning it, which makes learning a lot easier and even a lot more fun. So now that students understand the sizes of each rod, the teacher can move on to the second objective. And if the teacher wishes and time allows, they can have students come up to the board and show how they're getting some fractions for these size rods. In closing of that objective, before starting slide 3, ask students if there might be any other way to represent these fractions, just to get them thinking about the idea of equivalency and how they can be represented in different ways. Now you can begin to move on to slide 3. The assessment in this, they're informally assessed briefly throughout the slides, but more of the assessment comes from the second objective. The second objective. Students will understand what equivalent fractions are by the end of the lesson. This is again an understand level of Bloom, because they're just understanding what equivalent fractions are. They're not really applying any type of knowledge yet, they're just trying to grasp a knowledge of what equivalency means. The opening. After asking the students the question of if there's any other way to represent these fractions, you can move on to slide 3. So slide 3 just reiterates what the students have learned so far, the more or less important information. So 1 white is equal to 1/10, 1 red is equal to 1/5, 1 yellow is equal to 1/2, and the orange is equal to 1. So they are then asked the open-ended question, is there anything else we can find out? So now you may move on to, the teacher may move on to slide 4, and this is the beginning of the understanding of equivalent fractions. Students are given fractions for red and yellow. They are then shown how 1/5 and 2/10 are equal. On the projector, go through the process of finding these fractions. So they're given these fractions, so they already know them, and since it's the first time, they can walk through it and see how to solve for it. As a teacher, go through it on the projector with your rods, so they can see the methods you use to get there. So you'll have the red, and then you take 1 white and another white, and they'll be the same size. So 2/10 is equivalent to 1/5. So after they see that, they can move on to the next fraction with yellow. So when students see that yellow is equal to 1/2, and they have to figure out another equivalent fraction, they can use the white rods in the same method that the teacher showed them for the red rod. So the answer to this one is 5/10 and is again hidden with magic ink to the right of the 1/2 fraction. Have a pair of students come up to the projector to show their work in finding the equivalent fraction, and the bottom of the slide is somewhat of a summary relating what the equivalent fractions are. Again, 5/10 is hidden with magic ink to the right of the equal sign. The teacher can now move on to page 5. So this is the beginning of the assessment, and students are given 5 problems, and these problems have 2 different numerical valued fractions, and they have to determine if they're equivalent or not. So these are just yes or no questions. Again, all the answers are hidden with magic ink to the right of the problems, and if the teacher wishes, they can go through them one at a time and walk through the class observing students and picking students to come up to the board to show how they got their work, or the teacher could just go through the first one with them and then have them complete the rest on their own. There's many different ways to go about this, but either way, as long as there is some type of assessment, it'll be useful. All right. So question 5, however, is a harder problem because it's asking if 1/10 is equivalent to 2/20, and they don't have a rod that is equal to 1/20. So that's requires a little bit of a critical thinking method to solve. So if students are having trouble with that, you can go through that one with them alone, or not alone, together. So, all right. After this, moving on to page 6. This is the final assessment page. So now students are given a fraction, and they have to find an equivalent fraction of that. So the teacher may again have some students come to the projector to explain how they solved the problems, and again, all the answers are hidden with magic ink. So that's about it. The final slide is the congratulatory ending, applauding the students for completing the lesson, especially because fractions are pretty tough. And that's about it for the lesson. So in closing, re-ask students the essential question. So now they understand that 1/2 can be represented in other ways than just 1/2. It could be 2/4, 3/6, 4/8. There's an infinite amount of different ways to represent 1/2. So, and they will also understand that equivalent fractions are the same size, just really different numbers. For the second objective, the assessment is the final 2 pages, which contains the bulk of the assessment, and students have to determine whether or not fractions are equivalent, and then also determine equivalent fractions for a given fraction. If the teacher wishes, they can have students write down their answers on a sheet of paper and hand them in, or they can just go through the class and check them informally, or have them raise their hands. And that's about it. That's my lesson.